The mystery that spreads over the existence of the universe comes in great part from this, that we want the genesis of it to have been accomplished at one stroke or the whole of matter to be eternal. Whether we speak of creation or posit an uncreated matter, it is the totality of the universe that we are considering at once. At the root of this habit of mind lies the prejudice which we will analyze in our next chapter, the idea, common to materialists and to their opponents, that there is no really acting duration, and that the absolute, matter or mind, can have no place in concrete time, in the time which we feel to be the very stuff of our life, from which it follows that everything is given once for all, and that it is necessary to posit for all eternity either material multiplicity itself, or the act of creating this multiplicity, given in block in the divine essence. Once this prejudice is eradicated, the idea of creation becomes more clear, for it is merged in that of growth, but it no longer then of the universe, but it is no longer then of the universe in its totality that we must speak. Why should we speak of it? The universe is an assemblage of solar systems, which we have every reason to believe analogous to our own. No doubt they are not absolutely independent of one another. Our sun radiates heat and light beyond the farthest planet, and on the other hand, our entire solar system is moving in a definite direction as if it were drawn. There is, then, a bond between the worlds, but this bond may be regarded as infinitely loose in comparison with the mutual dependence which unites the parts of the same world among themselves, so that it is not artificially, for reasons of mere convenience, that we isolate our solar system. Nature itself invites us to isolate it. As living beings, we depend on the planet on which we are, and on the sun that provides for it, but on nothing else. As thinking beings, we may apply the laws of our physics to our own world, and extend them to each of the worlds taken separately, but nothing tells us that they apply to the entire universe, nor even that such an affirmation has any meaning, for the universe is not made, but is being made continually. It is growing, perhaps indefinitely, by the addition of new worlds. Let us extend then to the whole of our solar system the two most general laws of science, the principle of conservation of energy and that of its degradation, limiting them, however, to this relatively closed system and to other systems relatively closed. Let us see what will follow. We must remark, first of all, that these two principles have not the same metaphysical scope. The first is a quantitative law and consequently relative, in part, to our methods of measurement. It says that in a system presumed to be closed, the total energy, that is to say, the sum of its kinetic and potential energy, remains constant. Now, if there were only kinetic energy in the world, or even if there were, besides kinetic energy, only one single kind of potential energy, but no more, the artifice of measurement would not make the law artificial. The law of the conservation of energy would express indeed that something is preserved in constant quantity, but there are in fact energies of various kinds, and the measurement of each of them has evidently been so chosen as to justify the principle of conservation of energy. Convention therefore plays a large part in this principle, although there is undoubtedly, between the variations of the different energies composing one and the same system, a mutual dependence which is just what has made the extension of the principle possible by measurement suitably chosen. If, therefore, the philosopher applies this principle to the solar system complete, he must at least soften its outlines. The law of the conservation of energy cannot here express the objective permanence of a certain quantity, of a certain thing, but rather the necessity for every change that is brought about to be counterbalanced in some way by a change in an opposite direction. That is to say, even if it governs the whole of our solar system, the law of the conservation of energy is concerned with the relationship of a fragment of this world to another fragment rather than with the nature of the whole. It is otherwise with the second principle of thermodynamics. The law of the degradation of energy does not bear essentially on magnitudes. No doubt the first idea of it arose, in the thought of Carnot, out of certain quantitative considerations on the yield of thermic machines. Unquestionably, too, the terms in which Clausius generalized it were mathematical. In a calculable magnitude, entropy was, in fact, the final conception to which he was led. Such precision is necessary for practical applications, but the law might have been vaguely conceived, and if absolutely necessary, it might have been roughly formulated, even though no one had ever thought of measuring the different energies of the physical world, even though the concept of energy had not been created. Essentially, it expresses the fact that all physical changes have a tendency to be degraded into heat, and that heat tends to be distributed among bodies in a uniform manner. In this less precise form, it becomes independent of any convention. It is the most metaphysical of the laws of physics, since it points out without interposed symbols, without artificial devices of measurements, the direction in which the world is going. It tells us that changes that are visible and heterogeneous will be more and more diluted into changes that are invisible and homogeneous, and that the instability to which we owe the richness and variety of the changes taking place in our solar system will gradually give way to the relative stability of elementary vibrations continually and perpetually repeated. Just so with the man who keeps up his strength as he grows old, but spends it less and less in actions, and comes in the end to employ it entirely in making his lungs breathe and his heart beat. From this point of view, a world like our solar system is seen to be ever exhausting something of the mutability it contains. In the beginning, it had the maximum of possible utilization of energy. This mutability has gone on diminishing unceasingly, Whence does it come? We might at first suppose that it has come from some other point of space, but the difficulty is only set back, and for this external source of mutability, the same question springs up. True, it might be added that the number of worlds capable of passing mutability to each other is unlimited, that the sum of mutability contained in the universe is infinite, and that there is therefore no ground on which to seek its origin or to foresee its end. A hypothesis of this kind is as irrefutable as it is indemonstrable, but to speak of an infinite universe is to admit a perfect coincidence of matter with abstract space, and consequently an absolute externality of all the parts of matter in relation to one another. We have seen above what we must think of this theory, and how difficult it is to reconcile with the idea of a reciprocal influence of all the parts of matter on one another, an influence to which indeed it itself makes appeal. Again, it might be supposed that the general instability has arisen from a general state of stability, that the period in which we now are, and in which the utilizable energy is diminishing, has been preceded by a period in which the mutability was increasing, and that the alterations of increase and diminution succeed each other forever. This hypothesis is theoretically conceivable, as has been demonstrated quite recently, but according to the calculations of Boltzmann, the mathematical improbability of it passes all imagination and practically amounts to absolute impossibility. In reality, the problem remains insoluble as long as we keep on the ground of physics, for the physicist is obliged to attach energy to extended particles, and even if he regards the particles only as reservoirs of energy, he remains in space. He would belie his role if he sought the origin of these energies in an extraspatial process. It is there, however, in our opinion, that it must be sought. Is it extension in general that we are considering in abstracto? Extension, we said, appears only as a tension which is interrupted, or are we considering the concrete reality that fills this extension? The order which reigns there, and which is manifested by the laws of nature, is an order which must be born of itself when the inverse order is suppressed. A detention of the will, a detension with an S, of the will would produce precisely this suppression. Lastly, we find that the direction which this reality takes suggests to us the idea of a thing unmaking itself. Such, no doubt, is one of the essential characters of materiality. What conclusion are we to draw from all this, if not that the process by which the thing makes itself is directed in a contrary way to that of physical processes, and that it is therefore, by its very definition, immaterial? The vision we have of the material world is that of a weight which falls. No image drawn from matter, properly so called, will ever give us the idea of the weight rising. But this conclusion will come home to us with still greater force if we press nearer to the concrete reality, and if we consider no longer only matter in general, but within this matter, living bodies.